Hi, this is Lisa Wolf, and I'm auditioning for Lesson on Demand. So today we're going to look at a really interesting multiple figures problem in the geometry lesson of the GMAT. It's problem number 13 on page 952. And this problem is a really good example of a high difficulty question that is actually not as hard as it looks. It's one of the problems that has a very high intimidation factor. Students look at this and they become scared, so if you get this one right, you get credit for doing something that's a lot easier than it actually looks. You get credit for doing a hard problem when it's actually quite a bit easier. The other thing about this problem is, like many problems on the GMAT, it's very amenable to guessing. And I want to make sure that everybody here tries it and at least comes up with a guess, even if they're not sure what the answer is. Because it's a great way to hone your guessing skills by trying this problem. So let's take a look at the solution for the problem. The first thing is, we're going to use the first step of the Kaplan method and study the problem and of course the answer choices. And we look at the problem, it's a semicircle, and we're told point O is the center, PQ is parallel to OS, and we're asked for the measure of angle ROS. So that's the problem itself. We look at those answer choices. We've got a wide variety of answers ranging in the 30s to the 70s. We've got one answer there that looks like an oddball. If you were guessing, you probably would avoid picking this one simply because it's structurally different from the others. Doesn't mean that it can't be the right answer, but it's a little less likely. Now, if you want to do this problem, it would be a great idea to redraw the diagram, because you're going to want to be able to label angles and see what's going on. So on your own paper, you're going to draw a little sketch. Now, the number one problem that students run into with this particular math problem, and with others as well, they find themselves stuck because they've not used all the information in the problem. So always check, if you find yourself befuddled, have you used all the information in the prompt? In this particular case, the information that people often neglect to use is this one right here. PQ is parallel to OS. So why is that significant? Why is it important to realize that this line here, PQ, is parallel to this line here, OS? Sergey, any thoughts?
Because you can know the angle of QoS.
You can know the angle of QoS. And that's all because of the fact that this particular line here, QO, is what we call a transversal. This is a line that bisects two parallel lines. They're a little wavy the way I drew them, but they're supposed to be parallel. So if this angle here is 70, then as Sergey said, this angle here, QoS, would also be 70. And why is that important to us? Well, what is our goal in this problem?
ROS.
We're trying to get ROS. That is our goal. And here is R, write that in blue. So ROS is right there. And so if we were to label these two angles, maybe I would call them G and H. The one that we're looking for is angle H. So clearly, angle H is going to be smaller than 70, right? I mean, quite a bit smaller than 70. So 72 and 73 are right out of hand, and even 54.5 is looking like a dubious answer. In fact, even though we can't say that these drawings are, these diagrams are drawn to scale, we could estimate that G and H are going to be pretty close to each other because the additional angles are not very far off from each other. One of them is X, and the other one is X plus 1. So only differing by 1 degree up there, and at least that corner angle. So we know G and H are going to be pretty close. And the two remaining answers, 34 and 36, are also pretty close to each other. So that's looking like a good bet right now that the answer is one of them. So if you're guessing and you've guessed A or B, you've done a great job here, which both of you did, in fact. But let's see if we can actually come up with the answer here. So we've got this information that G and H together add up to 70. Maybe we should just write that down in case we need it later. And now we're trying to figure out what angle H is. Well, what do we know about this figure, ROS? What kind of figure is it, Sergey?
Triangle.
It's a triangle. Any special kind of triangle? Well, remember, this figure is a semicircle, and this is the center. So what would you say about this line, OR? That's got to be It's got to be a radius. Yes, he said isosceles. It's got to be a radius of a circle, and this too, OS, is a radius. So what we have here is, in fact, an isosceles triangle. Great job. So R to O, S to O, they're going to be the same length because they're radii. Since this is an isosceles triangle, this base angle, x plus 1, is going to be the same as this base angle here, x plus 1. And these three angles, x plus 1, and h, will add up to what? What will they add up to, Tim? Angles of a triangle all add up to
180.
180, perfect. So x plus 1 plus x plus 1 plus h equals 180. Now, likewise, we have another triangle here, QRO, which is also an isosceles triangle, right? So this base angle is x, this base angle is x, and that angle there, g, are all going to add up to 180. So we could say x plus g equals 180. All right, so since this piece equals 180 and this piece equals 180, they clearly equal each other. So rewriting that, we can say 2x plus 2 plus h equals 2x plus g. Now, what do these two sides have in common? They both have the 2x, so we can subtract that from both sides, leaving us with this equation, 2 plus h equals g. Well, remember, what we're interested in here is h, angle h. That's our goal. And we have 2 plus h equals g. So which one's bigger, g or h? Turkey?
G should be bigger.
G should be bigger because I add 2 to h to get g. So g is bigger than h is smaller than g. So of these two angles, we have 34, 36. Interestingly, they're 2 degrees apart. So it looks like this one is the angle that we're looking for. The smaller one is h, 34 degrees, and the bigger one is g. Now, if you got stuck at this point, if this was kind of like a conceptual barrier and you're like, oh, I can't figure out which one's which, you could then take this one and this one, put them together, and solving two equations, two unknowns, come up with the value for h. The degree measure of h would be 34 degrees. Okay? Any questions? Great job, thank you.